Hey, what's going on, guys? Games here. In this video I'd like to announce a beginning of the new series introducing the Bitboard CHESS ENGINE video tutorial series, starting from scratch, absolutely from scratch, and ending up with a chess engine that actually can play versus other engines using the UCI protocol. And before I start this quick overview of what in particular we're supposed to be doing within this tutorial, let me first please give some credits and show my appreciation basically to the TalkChess forum community. So yesterday I was so upset, and I was thinking like, what I'm doing on this chess programming channel, like nobody really cares about it, and I wanted to get some feedbacks, and like I didn't actually post any videos and didn't give any material on TalkChess forum regarding my chess programming channel because I consider it to be too miserable for those guys who actually talks there, and I didn't really think that it might be interesting to them at any point. And I didn't even describe why exactly I do think so. I'll probably just give you a link to that forum post below this video to give you an idea, like what am I talking about. But surprisingly, I get so many nice positive feedbacks from the guys from TalkChess forum. So eventually this motivated me to continue my work and even start with this long and hopefully, like I mentioned here, never-ending series with new improvements and tests on creating a Bitboard chess engine from scratch, and then just going on developing it just like all the other guys on TalkChess.com do. But the difference is that it would serve first of all the didactic purposes, and secondly I would like to cover every single step being made on writing and improving this chess engine in a video format, so you guys would be able to follow the process of how chess engine borns and how it grows and so on, and hopefully never dies. So I just want to share another proud of mine here. So among others, I had a very valuable feedback from Gerd Isenberg himself, believe it or not, and it's a little bit of irony in his response, but still, like, to get a feedback from a man of his caliber is the great honor for me. So he says, like, for novice target group, didactically not so bad. Let me just minimize this window. I just had a look at the first Bitboard tutorial, is this agile programming, and I did provide an extended answer to this question. But what surprised me the most basically is that Gerd actually added the link to this chess programming YouTube channel into chess programming Wikipedia, believe it or not. And this is such a great honor for me, so just I'd like to proudly show you this link. So here is the link for my chess programming a link to my chess programming YouTube channel that you're currently watching video from, and this is absolutely fantastic. I never even dared to dream that this sort of stuff would happen one day, and obviously this motivates me so strong, so that from now on I will keep serving the chess programming community even more. And also in the initial forum post, I've been mentioning that I was inspired by the chess engine in C by the Blue Fever software, and it's so nice to see my name just right after the Blue Fever software's name, and in this list to kind of stand in the same line with him. And also Logic Crazy is here, and I did even see and the Karakans, the guy I've been mentioning, actually is available here as well with his chess engine in Go, while I thought that is not available in chess programming Wikipedia. Anyway, this is so I'm so proud to be the part of it, and I really want to thank all of you guys for supporting me, giving your feedbacks, and special thanks to Gerd Isenberg for making this chess programming channel a part of the chess programming community using this link in the chess programming Wikipedia. So I'm really so grateful, guys, and I'm really so happy that you kind of accepting my work here and what am I doing basically. And also I would like to thank all those of you guys who has subscribed to my channel after reading this post on TalkChess.com. I didn't even mean to post this to gain more subscribers. I mean, really, you know, like I just really wanted to get some feedback, and the fact that some of you guys actually has subscribed, and I think that there is that not only kind of novice how do you call this, novice target group, not only guys from the novice target group, but I guess that also the guys who are writing their own chess engines much better than those that I have ever written are also subscribed to this channel and following this, and that's the great order for me as well. So without further ado, let me actually jump into the explanation of what in particular we're supposed to be doing within this series, and how exactly we're supposed to be proceeding, and what's the engine's concepts and reasons to create it. So the reasons to create it has just been described by me, and now a few words regarding the engine concepts. So I'm trying to focus on chess programming rather than best practices of C programming. So I'm sacrificing really lots of things like which I consider to be the best practices in C, like encapsulating data using the structures and passing pointers instead of using global variables and things like that. But when I was initially following the Blue Fever software series on chess programming, programming chess engine in C, I remember that I had a poor C programming language skills, and it was incredibly difficult for me to walk through all those complicated. They are not complicated really, but at that time those C concepts, low-level programming concepts, seemed to me really complicated, and I really wanted to focus on chess engine development itself rather than on those C-related stuff. So that's the reason why I would be trying simplifying C code as much as I can, and I've already tried that within my previous chess engine named Wukong, which is based on hexadecimal 88 board representation, and mostly covered in several series on this chess programming channel. So you can have a look at the style of code and how it looks like. It's heavily commented, and some of you guys pointed that out kindly on TalkChess forum, which I'm really grateful for again. So assuming that bitboards are really complicated itself, and I mean they're not really that complicated, but they involve really lots of bitwise operations, and all your consciousness would have been needed to get the concepts of what in particular we're doing with all of these bit shifts and things like that, because so I just don't really want your consciousness to get distracted by some complicated C programming language related things. But obviously for those of you who is proficient in C programming language and have an experience writing that, you can go your own way. So even though this series is intended to be a series of tutorials, like every next video would be depending on the previous ones, still you're free to go for your own implementation. So I'm going to be defining the bitboards globally, and variables to represent the board state like side to move and peasant square and castling rights and king squares. I would be representing all this stuff as a global variables, and then I will go for a copy make approach to copy the board state before making a move, but this would be covered a little bit later on. So anyway, the idea is that if you don't like this approach, you can always go your own way. You can encapsulate your bitboards within the board structure and do whatever you want basically. So my idea is again like to focus on the bitboard techniques and the principles that regards chess programming, and emphasize the chess programming and the bitboard stuff rather than C programming language stuff. So just bearing this in mind, I hope you will understand the reason why I'm supposed to be using probably slightly weird stuff from the C programming language perspective, but hopefully quite pretty clear stuff from the chess programming perspective. So you probably know, so if you have been researching someone else's chess engines, especially those involving bitboards, you probably see that sometimes it's incredibly hard to dive through their source code because it's really personalized, and you're more like seeing like how a person lives, how a person thinks, and then you just see how he implements the bitboards. And what I'm aiming to achieve in this series is absolutely on the contrary. So I would like you to see everything that regards bitboards and try not to show in my personal stuff, just to avoid your consciousness getting distracted by that. So I hope this is quite pretty clear, and if not, please feel free to leave the commentaries below this video, and I would be happy to answer these like questions in greater detail. So now the next thing to consider is the development environment I'm supposed to be working on. So I'm a big fan of Linux. I'm a Linux enthusiast as well as a chess programming enthusiast. So like Linux is some sort of my religion, and I don't really like Windows. I don't use it for years already, and I will never ever get back to Windows. But obviously I know that many, if not most of you guys actually using Windows, and someone, a guy on TalkChess forum already told me that he had some issues with compiling some parts of my code using the Visual Studio. And even though I'm trying to, well, let me just show you the makefile to make makefile speak instead of me. So I'm maintaining two versions, the release version and the debug version. The difference is that the release version contains this basic optimizations flags, but at the same time I'm not only using the GCC compiler, which is the standard Linux compiler, GNU C compiler, but I'm also using the cross compiler. This is called GCC MinGV, and it allows to produce 64-bit binary executables for Windows. So I'm not sure if Visual Studio is actually using some Microsoft compiler by default or something, but I almost 100% sure that if you would be using this MinGV GCC compiler, which as far as I'm aware, it probably goes with an ID called code blocks. It seems like it's coming there as well. So you can either try to install the MinGV on your Windows itself, or just as a part of code blocks, and then you would be able to use it in order to compile the sources. So I'm not using IDs. That's kind of, again, like let's say that's the matter of religion. Well, so I always I used to go good old school way, like Blue Fever Software did. The guy, the author of the legendary programming chess engine in C series. So he was doing this. He was writing the code just right in the text file, and then compiling it within the command line. And that's the exact way I'm following in all my tutorials, basically. All those tutorials that are already available on this chess programming channel. So again, like I highly encourage you guys to use this MinGV compiler. Not this is the cross compiler to make binary executables on Windows. So even if you will have some issues with compiling this stuff, anyway, you would be able to run the binary executable eventually on your system in order to being able to actually see the output of the program in the in between intermediate stages of the development process. But again, like in case of having issues with the compilation, I highly encourage you guys to instantly leave a commentary below that the video resolved that issue. So I would be either trying to help you with your compiler if you provide me some compiler error logs, or and I'll learn the code respectively, or again, like maybe that would be possible just to change the code slightly a bit to make it fit the somewhat else compiler. But again, like as far as I'm not a fan of Windows at all, so I never use Microsoft compiler, and I'm not going to be doing this even if some Microsoft compiler is available on Linux, and I will go for good old GCC anyway. So I guess that just installing this min.gw GCC on your local system would actually resolve this possible compilation issue. So I hope this is it regarding the development environment, which is literally the code editor or just the bare text editor, and the compilation using this GCC compiler in the command line. And also, please know that now I'll go to some drafts that I've already done regarding the source code for the future chess engine that we're supposed to be developing. Don't research it too much. It's just a draft at the moment, but it would have this like visual delimiters to highlight the very important parts within the code. Like here we have the bit manipulations, everything that regards this, then the input and output where we can print the bitboard, print board, parse in FEN, string and things like that. Some then we're going for generating Lipper piece attacks and handling all the off-board conditions to avoid pieces capturing off-board, and all the functions related to generate the pre-calculated attack tables for Lipper pieces. And then we'll go the same way for slider pieces using the magic bit boards, and here I already have the pre-coded magic bit boards. Not sure yet if I'm supposed to be making a video on how to generate this magic bit boards, but anyway, there would be a video of how to create all the helper functions and to initialize the bishop and rook attack tables, the pre-calculated bishop and rook attack tables involving so-called plain magic bitboard implementation, where the attack tables themselves looks like this. So we have two-dimensional arrays, and first serves for the piece on the being landed on the target square, and while the second serves for a so-called magic index to take the appropriate attack set, assuming the current occupancy on board from the corresponding attack from the corresponding pieces attack table. Okay, so this is kind of it. So we'll probably start with generating attacks and then go for all the other stuff basically. So here we have, yeah, I just had this is the code from my standalone bitboard tutorials, but even though I tried to make them standalone, it already looked like a series. But I just don't really want to continue that one because the concept was different. So I would rather be rewriting this completely from scratch again. Probably grouping the material slightly different than in the standalone bitboard tutorials playlist on this channel. So to emphasize the most, and to emphasize and to highlight the most important parts again, because it would never be too much if you emphasize the very core parts of generating attacks for pieces in general. So this is it regarding the development environment. And now I want to quickly walk through the list of the features that are planned to involve within this Bitboard chess engine that we're supposed to be making on this channel. So Bitboard board representation is quite pretty clear itself, I hope. So the pre-calculated attack tables for pieces. So instead of generating attacks on the fly, we would be making this pre-calculated attack tables for Lipper and slider pieces, as was just explained, just like it was explained already. So the idea of using the pre-calculated attack tables is just to save the time on calculating the attacks on the fly and just use the lookup within the attack tables for both square attack function purposes and for move generation purposes as well. We also would have been coding moves as integers, as we did already in the previous hexadecimal 88 chess engine series, and I've already covered that, but I would be happy to go and cover it one more time. So here are our stuff, some macros to encode move, and so we would have been encoding the source score, target score, promoted piece, capture flag, double pawn flag, and peasant flag, and castling flag. and some macros to extract the corresponding data, the corresponding encoding parts from the move itself. So this is again, like, this is faster compared to if we have a move structure. And also, as I was already mentioning, I would be trying to avoid structures to make it easier to not get you bothered by with passing of all these pointers to the structures and things like that, because I just want to make this as simple as possible and emphasize on chess programming rather than on best practices of C programming. So again, like, feel free to implement this on your own. My goal is just to highlight the core concepts, not the implementation. So I sacrifice literally everything just to make it as didactic as possible, just to highlight the chess programming principles and try to make it trying to remove my own personality from this as much as I can, so you would not so you don't see me and my habits and what I do, but instead you see just the pure chess programming instead. So that's the idea. Okay, so let's move on. Also, I would be using the copy make approach, so-called copy make approach for making moves. The idea is very simple. We can either make move and update really lots of things, like in peasant square, setting peasant square and double pawn push, updating castle and rights, moving piece itself, handling captures of the pawn on the peasant captures, handling pawn promotions, and so on. The first approach is just do all this stuff incrementally, updating the board state within the make move function, and then do all the same but in the opposite direction within the take back function. But instead of doing this, instead of actually doing this incremental update back in the take back, we can just preserve the board state before making a move, and then we just can restore this board state back. And even though it's slightly worse from the performance perspective, still it's far easier to understand and to implement compared to going for make move and take back approach. And from the chess, from the resultant chess engine performance and strength of play, it doesn't really matter that much, because when we're talking about the engine strength, it's more about the search algorithms, optimizations using the move ordering and transposition tables, and also obviously a great work done on the evaluation function. So those are the most important factors that actually affect the overall strength of the chess engine. Well, the speed. Well, even though that the speed of the move generator is actually also affects this obviously, but you can make a really fast move generator, but if you don't provide move ordering within your search algorithm, your engine would suck for sure. So just to highlight these points as well. So that's the reason for why we're supposed to be going for this copy make approach. Okay, so probably I wanted to say something else, but I sort of just forgot that. Okay, so obviously we're gonna be using the NigaMax framework and followed by the alphabet of pruning, and we'll provide some very basic move ordering. So principal variation move would be ordered first, then the killer moves also that is produced by the beta cutoffs within the alpha beta search would be scored next, and last it would be scoring the so-called history best moves, which produced when the alpha increases within the alpha beta search. So every time alpha increases, the history move would be recorded and then would be ordered accordingly. So to make it like this, transposition tables in general, you know, like they needed in order to not search what you've already searched. And by the way, also I forgot to add the iterative deepening here, so let me just try to add this iterative deepening. Okay, obviously, because you know, like it's better to use to search, not going searching for the given depth at the moment, but starting from depth 1 and then going to depth 2, 3, because first of all we would be getting this principal variation moves to search them first within the next iterations of the search itself, and Anyway, iterative deepening. Anyway, the initial idea behind the iterative deepening is obviously the timing, assuming the UCI protocol connecting the chess engine to the GUI, so we can drop. So say the time is up, and we need to make a move, or we just got a stop command from the GUI. So so iterative deepening would allow us to return the move from the depth that has been achieved so far, even though say it has a best move at depth of 5, but it's now trying to search the best move at depth of 6, and it didn't yet complete the search and already got the stop command from the GUI, so it would just drop back, returning the best move so far from the depth of 5. So that's the main idea behind the iterative deepening, but also it shows to be quite pretty tempting to use in order to improve the move order in itself. So using iterative deepening allows you to traverse overall less number of nodes if you don't use it actually. So that's kind of it. So transposition tables, just to not search things twice, which is absolutely interesting and fascinating topic itself that I don't even want to start talking about at the moment. And then one of the most essential parts, and one of the reasons why people actually use bitboards, believe it or not. So it's not only about making the move generator faster, even though the bitboards are faster than the array-based board representation, obviously in case if you can set it up correctly and make it and fine-tune it, basically. Only in this case, because my initial Bitboard chess engine that I created some years ago was actually 5 times slower compared to the array-based move generator, and that was a real pain that days, I remember. But obviously, if you do everything correctly, that the Bitboard move generator should be and would be actually faster. But it's not the main goal. So one of the most problems with array-based move with array-based array-based board representations and move generators currently is that it comes to the point that so you start adding some new features to your evaluation functions, and the more features you add, the slower your evaluation function becomes, and the slower and the overall performance of your chess program actually goes down after all, and that's not really that great. So there are really lots of stories from chess engine developers who started developing their engines using the array-based board representation, and then eventually, when their evaluation function started to be really huge, they started realizing that it's time to go to bitboards, because in bitboards it's far less expensive to do literally all the same that you do when you're using the array-based board representation. So let's say the pawns. So you want to evaluate, say, passed pawns, isolated pawns, double pawns in bitboards. It's just a matter of couple bitwise operations. While in case of array-based board representation, it starts involving extra for loops to initialize some data structures that would be providing some lookups for a pawn structure and things like that. So first of all, it takes more code, firstly, and secondly, it just slows the overall performance of your chess engine quite pretty significantly, which is not the way to go, basically. And exactly, the evaluation function is the most the most important, probably the most important part that can make use of the bitboard board representation. So we can evaluate positions not expensively, so we can do it quite pretty fast without getting our overall performance down, without slowing it down. But at the same time, we can just answer all those questions like king safety, pawn structure, piece mobility, at least this very basic things firstly. And yeah, so that's just a fact to bear in mind. And finally, we'll obviously implement the UCI protocol, allowing our engine to connect to the GUI and not only going for a fixed depth like I did in my previous series, but also involving some timing, allowing engine to stop when the stop command is received, making it plain blitz or longer time controls. So just we're going to be implementing quite pretty solid UCI protocol that would already allow the engine to participate in the tournaments with other engines, getting ready and things like that. So not the UCI placeholder I've been using so far, but something really more interesting. Obviously, assuming obviously bearing in mind that we would be implementing the transposition table, it would will need to set the space of the memory occupied by the transposition table. So we would be making use of the UCI option set hash size. I'm not sure exactly how is that called, but the idea is like you probably know that the engine like occupying 4 megabytes or 32 megabytes or 512 megabytes for the transposition table basically. And the more transposition table is, the less job has to be done during the search, and the more lookups are getting available. So that's quite pretty simple. So and eventually we have an ability for our chess engine not to be kind of limited by the depth of 6, 7, or 8 plies, but just go for 12 plies and even more. And assuming the longer time controls, we can go even more. So that's the magic behind the transposition table, basically. So this is it, basically. This is it, guys, regarding the feature list that I'm intending to implement at this very starting point of the development process. So matches versus other engines are obviously about to come, but just when the engine is going to be ready. And again, like if in the previous series I was trying to make the engine play versus other engines as soon as possible. This time I'm not going to be doing this, so I have no idea when these first results are about to appear, because the matter of implementing these features is kind of big job, and assuming that making videos along the way, it's even twice more job, to be honest. But so we're not gonna be rushing anywhere, so no hurries basically. And I would rather like to emphasize the quality and the tests and make sure that everything actually works, rather than trying to make it play versus other engines, to make it lose versus other engines as soon as possible. So I'm not going for that. And before I end this talk, basically, just want to highlight one last. Just want to credit and highlight one last commentary, one last post from TalkChess forum that I got from one of the guys there. So he asked me. I was asking like, what kind of format would you guys prefer for this chess engine tutorials? And someone, a guy, told me that he would prefer the Bitboard tutorial from scratch to the engine that would beat TSCP, and that won't be limited by the search depth, and it wouldn't involve the Bitboard implementation. So probably these conditions are about to be set up as the very first go. So not being limited by the depth search only. So we're going to be using transposition tables for this, and the UCI protocol allowing to manage the time controls, and the Bitboard the Bitboard board representation fits the the request of having the Bitboard chess engine actually, which is already good, and the requisite to beat TSCP. Well, even so, the chess engine that I've already created on this channel did all the same that was involved here. So he had all these features apart transposition tables, and he had only depth fixed UCI protocol. And that engine was playing for about 1600 points of elo. It's obviously it's lower than TSCP. TSCP, according to CCRL, Computer Chess Rating List, is about 1683, if I'm not mistaken. So the engine I was making was for about 1600s, maybe a bit more. I can't say for sure. I didn't test it that heavily to get a real rating for it. But just I just want to say that the search algorithm being involved in the engine that I've created in the previous series were absolutely the same like in TSCP. The only thing differs is that TSCP doesn't have killer moves, killer heuristics, so it doesn't order the killer moves produced by the beta cutoffs. But all the rest of stuff is literally the same. But TSCP has quite pretty nice evaluation function that the engine I was making really didn't have those features for. Pawn for evaluating pawns, piece mobility, and king safety at all. So it only evaluated the material and the positional piece scores. So that's the reason why it was actually playing weaker compared to TSCP. So with this bitboard representation of our board, we'll have opportunities to improve the evaluation function significantly to make it faster than TSCP's one, and using the transposition tables would allow us to outcome TSCP significantly because of the depth that the engine would hit in the same amount of time, because it would really go deeper due to the savings reached thankfully to the pre-stored scores within the transposition table. So this is it regarding the feature list, mentioned versus other engines, so hopefully covered as well. And the very last point, never-ending improvements in new tests. So what I dream, I have no idea if it's gonna work actually or not. What I dream is actually never stop this series, never to keep this series going forever, basically. Well, at least in my dreams. But the only issue that I might encounter that I can't really calculate or evaluate at this moment is, as far as I'm sacrificing lots of best C programming language practices and we're trying to make to rely mostly on global variables, and also would try to, just like in my previous engine series, I would try to keep the modularity, so like the move generator won't affect the search, and the search like I was doing before. I mean, like let's say the move ordering, like right. So usually it happens that the moves are getting scored during the move generation purpose. But what I did was actually to score moves after the move list is already generated. It's slightly worse from the performance perspective, but it's much better from the modularity perspective. So you can have no idea regarding how the move generator works, but start with the search algorithms and already get a chess engine that actually plays chess better and better as long as you're improving the move orderings and things like that. So I know this might sound a little bit weird, but obviously well, I would be trying to follow these guidelines just because this is the idea of this entire chess programming channel. Because those of you guys who has an experience of creating like 2500 elo points chess engines, obviously you know that you would rather sacrifice everything for the performance. But I have a slightly different goals, and I'm not ever about to compete with those of you who create really strong chess engines. I just want to make chess programming as easy as possible and try to make it reach to the maximum number of people out there on YouTube and worldwide, basically. So that's the goal. And having this basics, having this pure understanding of the algorithms of the process of creating the chess engine itself, you would be free to go for your own implementation and expressing your own personality within your chess engines and actually going for increasing the L points of your chess engine. So I'm not sure regarding the possible pitfalls that I can get into, assuming the didactic approach I'm using here. So maybe it happens one day that I won't be able to go using this didactic approach anymore. So maybe either I would need to sacrifice the didactic approach one day, or maybe I don't know. So that's too far. That's behind the horizon. So just like the horizon effect, the alphabet search is suffering from without the question search. I just can't really say what exactly is gonna happen in future. So at this point, guys, I'd like to thank all of you for watching this video, for new subscribers. Thanks for following this channel, and I see you in the next videos. Actually, starting from the next video, I would already start covering. So I would actually start writing this Bitboard Chess Engine from scratch, and see you there, guys. So thanks for watching. Until the next time, and take care.